Our research addresses the critical challenge faced by first responders, navigating overwhelming real-time data during high-pressure situations. FirstModulAR aims to streamline decision-making, reduce cognitive burden, and equip first responders with the tools to act swiftly and effectively in emergencies. To tackle these challenges, we explore AR/UI interfaces using a modular design approach. This strategy allows us to build adaptable, hardware-independent AR modules that seamlessly integrate into comprehensive interfaces tailored to various first responder use cases. The Information Display module in FirstModulAR enhances situational awareness with 3 display metaphors. 1, on demand, shows information only when requested, reducing distractions. 2, environment anchored, overlays data on physical objects or locations for context-aware displays. 3, body anchored, displays information on the wrist or other body parts for quick access. The quick access radial menu allows for rapid selection and confirmation. Users can summon the menu with a double pinch gesture and choose options by moving their hand to the desired choice. It dynamically adapts to the scenario and available actions, presenting relevant options and enabling sub-level navigation for more detailed selections. Another significant component is the notification system, which provides non-intrusive alerts through peripheral visual effects and auditory cues. This system ensures that critical developments, such as hazardous conditions or incoming instructions, are communicated effectively without overwhelming the user. Alerts are categorized into 3 levels: low, moderate, and high priority, each with distinct visual and auditory representations. The navigation module enhances spatial awareness and guidance through ground overlay, augmented guidance with directional cues projected onto the ground, 2D blueprint, a floor plan of the environment displayed on one of the information displays. Edge detection visualization highlights objects with outlines for improved visibility and context in complex spaces. Points of interest placement allows users to mark and share details about the environment for navigation and collaboration.
In this EMS scenario, the user has been called to a site where an unconscious civilian is suspected to be suffering from an opioid overdose. The user navigates to the Procedures tab and selects the procedure for administering Narcan. Around the same time, the spatialized vitals display, positioned above the patient's head, begins to alert, indicating a dangerously slow heart rate and dangerously low oxygen saturation. These symptoms are aligned with the patient's suspected state of being in an opioid overdose. The user gets down on the patient's level and consults his wrist-mounted procedures display, receiving step-by-step instructions. Once each step is completed, he uses a special radial menu to indicate he is ready to move on to the next step. Following the procedure, the user administers Narcan to the patient. The user patiently monitors the patient's vitals, checking to see if the medication is helping. In this firefighting scenario, the user has been called to a burning building where a helpless infant is known to be stranded somewhere inside. The user summons a panel interface with a flick of his hand. Using a pinch and drag gesture, he zooms out on his map interface, revealing a special point of interest icon which represents the baby's known position. The user clicks on this icon, then selects the Navigate option, which will direct him to the baby's exact location. Spatialized arrows appear on the ground, giving the user a precise route to his destination. He then uses a double pinch gesture to toggle on a special edge detection visualization mode, which draws an outline around objects in the room. Even though the user's vision is completely obscured by heavy smoke, the combination of the navigation arrows and the edge detection outlines makes navigating through the environment trivial. On his way to the baby, the firefighter quickly checks the level of air remaining in his SCBA by consulting a wrist-mounted gauge interface. The firefighter navigates to the baby in seconds, when it might have otherwise taken minutes for the user to painstakingly search each room. After rescuing the baby, the user is able to use the same tools to easily navigate out of the burning building. We demonstrate a potential use case of augmented reality interfaces, acting out the scenario of a police officer who has just pulled over a vehicle for a traffic stop. Rather than having to manually type in the vehicle's license plate, the officer can simply look at the license plate and press the scan button. For this demo, the license plate has been covered with a special symbol that is easy for the AR headset to detect. The interface will automatically display the data of the scanned vehicle, including registration dates, owner, make and model, etc. After scanning the license plate, the officer walks to the driver's side window and asks to see the driver's ID. Similarly, the officer can just scan the ID card in order to view the driver's info. In this case, the interface is a red flash and plays a warning sound effect to indicate that the data lookup has yielded critical results. For example, an active warrant out on the driver.